Hello, everyone. Thank you for taking the time to join us today for the second portion of our 2D Programming in PowerMill webinar. I'm joined once again by Mike Belanger of AMS 360, who will be leading the technical presentation. We also have the fortune of having Aaron Kennett from Autodesk on the line as well. Aaron and I will be monitoring your questions throughout this demonstration, and we'll either send you a message response or address this during our Q&A segment. Having a look at the agenda, you'll see we're going to be following the same format as last time. We're going to keep this presentation on point and tidy. And I would actually like to remind you that all microphones will remain on mute, but certainly we welcome your questions and feedback along the way. So please take a quick moment here and find the questions tab on the GoToWebinar panel. Should be just off to the side there. Key in your comments along the way. And as I said, we will collect them and bring them about on the tail end of the presentation for the Q&A, or just simply type in a response. So let's get right to it. Please take it away, Mike.
Hello and welcome everybody. Thanks for signing up to watch today's webinar. Big thanks to those who are returning that watched the first part to this webinar about drilling and drilling methods. So to start off, I'm just going to give you a small taste of what I talked about last time in case you missed it. I will give you a quick glimpse of the finished result from that project. So this is the project from last time. As you can see, I've brought in the plate here. I have the feature sets created already. And I have just the method that I created last time. No toolpaths yet. As you can see, we only have this one drilling method. Now, if I take a quick peek at this drilling method, you can see I have 3 processes built into it right here. Each one of these processes represents a different style of hole. Now, as far as drilling methods go, once you have them built, you can simply open them up and just hit apply. Once you apply this drilling method, it starts to go to work. It interrogates the job, looks at the feature sets that you have, builds all the strategies that you need as long as they fit within the criteria of the job that you have right here, and then spits out ready to use toolpath for you. As you can see, that was pretty quick. Okay, and we have a good handful of toolpaths here. Now, if we take a closer look at the toolpaths themselves, you can see we have very simple drilling style toolpaths. There's nothing really groundbreaking as far as the actual strategies go. It's just a matter of having them done. Let's say that was well under a minute. We had all of these toolpaths calculated. So we got our center drill through, we got some helical to do that bore at the top. Similar operation over here, except it's tapping. And then we have some other operations for these fixture style holes, which do a center drill, a helical that also does that chamfer at the top, rough and finish bore, and then also I added in some thread milling, which is common in many shops. So if you were one of the ones who did happen to miss this previous webinar, Rob and I would be more than happy to share the link with you for the recording. We will have our contact info up here a bit later on, or I believe there will be some emails that are sent out. You can reply that way and just let us know, and we'll send you links out for that information. So to continue on from the 2D drilling methods portion that I covered last time and recapped it just now, we're going to talk more about the 2.5D features in this plate. You will see right away that we have these green slotted areas. We also have these orange side pockets that are approximately halfway down the depth of the plate. Over here we have some purple side cutouts that actually go all the way through the plate. And then finally we have these large blue bored holes that go through the plate that drilling just would not be a logical solution for. So I'm going to go down here and open up a fresh new session of PowerMill. You will see that I have only the plate loaded in here along with a few basic tools for use. Curve machining is basically making a pattern along an edge or anywhere you actually need it, and then the tool will drive either along that pattern or with the tool's edge along the side of that pattern. So let's address this orange pocket as our example. So like I mentioned, we're going to create a pattern, and I'm going to use the curve editor to create a composite curve. I'm going to trace this edge all the way along the top, and save it. Next, I'm going to activate my 1/2" end mill. And from my strategy selector, go to my curve machining options and choose 2D curve profile. The 2D curve profile is pretty straightforward, but there are a few options that you need to be aware of. First, we need to choose the curve, obviously, that we selected. Next, we need to go just to the right of that form and interactively modify the machinable sections. So when we open this up, we can see that there is a tool, a representation of the tool on a side of the curve. Sometimes it might come in on the right side or the wrong side, and you can edit that very easily from the ribbon up top, or choosing or clicking on the tool itself will switch the sides. Once you're happy with that, hit the green check mark to accept those changes. Next, we choose whether we want the tool's edge to run along the pattern or the tool's center to run along the pattern. Obviously, in this example, we are going to be running the tool's edge along the pattern. So with curve machining, it doesn't look to the physical model that we are machining, so it doesn't recognize maybe the floor or this geometry right here. So what we need to do is define the lower limit, and that is pretty easy by clicking on the button and just selecting that face, and it automatically inputs that Z value right there. Alternatively, if you know the value, you can type it in with your keyboard. Tolerance and thickness is pretty straightforward. As a PowerMill user, we know how to do that. And I'm going to go over to this cut distances page. So for my first operation, I'm going to choose my vertical step downs to be 50 thou and my horizontal to be driven by a stock width of 3 inches and a step over of 300 thou. Next, I'm going to take a peek into the automatic verification just to make sure that my model gouge check is turned on, because I do want to make sure that we don't gouge any surfaces, and that it does, after the toolpath is created, check for those gouges. And I will calculate that toolpath. So there we go. We have a roughing style toolpath made from nothing but a curve. And we can see it clears all the material that we need. And in fact, I actually have some leads and links put in here. My lead ins and lead outs are both set to an extra 1/2 inch distance. So it clears out and away from the material so the tool is not plunging onto that raw stock. All right. The next operation will be again in the curve machining. I'm going to use the same toolpath, 2D curve profile. Same setup. I'm going to leave all this the same. I'm going to put the curve thickness down to 0 thou per side, and I'm going to treat this like a finishing pass. So my cut distances, I will leave the same at 50 thou, and in fact, if you want, you can increase that number because of the small amount of stock that is remaining. Now my stock width, I'm just going to put it at a minimal size so it doesn't feel the need to step over more than the tool diameter. So there we go, have a profile finish pass for this pocketed area. Okay, so I'm just going to copy that tool path, and I'm going to make one more tool path to machine the floor of this area. And it actually works quite easily. I go into my cut distances. My step down I'm going to make quite large. I know that this distance is 1 inch, so my step down is set to 1.5 inches. My stock is set back to 3 inches and my step over at 0.3. Now when I use those settings, we can see we get a nice, clean, simple tool path along the floor to finish that operation. So let's shift gears and talk about feature machining. Close this up. Take a step back and look at some of these other features that we have on this plate. Let's start with this green slot here. We can see that we have 4 of them. And I'm going to, in the same vein as creating a whole feature set, create a feature group. Now to create a feature group, we see them here in the tree, just like all the other items that we create in PowerMill. And I'm going to use this detect features to interactively go through this model, and as I hover over all of these items, you can see it detecting a feature that can be machined. So like I said, I am going to deal with this green slot, but as we can see, there are similar ones around, and there is an option for that in the feature machining. So once I click on similar and choose that green slot, we have them all selected. Accept that form to save my selection, and I now have a feature group right here that has my green slots in it. Now I can have a look at my strategy selector under my feature machining options and choose what toolpath works best for me. For this operation, I'm going to choose Feature Pocket Profile. All right, so you can see that it's automatically selected the features that I've already created, the ones that are active in my Explorer. But from the left-hand side Explorer inside the toolpath, you can easily deselect or reselect the ones that you do or do not want. Okay, I'm going to leave them all selected for now. I'm going to undraw my model, and I'm going to do a quick measure. And find out that this is 1.5 inches in width. So I'm going to choose the appropriate tool. I'll say a 1-inch tip radius tool. And go through the process. All right, I'm going to choose to climb cut. Tolerance and thickness are set. My step down. And apply. So if I take a close look, I can see I have this tool path that goes inside the slot following this dynamically picked feature from inside PowerMill. I do have some lead-ins and lead-outs that I'm going to remove from the tool path right now that were brought in from the previous settings. and that feature is done. Next, let's have a peek at these purple style through slots on the ends of the plate. Okay. With the green slots, we allowed PowerMill to pick the features for us using the automatic method. And in this example, what I'm going to show you is a more manual way to pick the feature. So again, I'm going to create a feature group, but this time in the feature group, I am going to use the editor. I'm going to create a side feature. And then from this first, you notice there's a number of tabs here. From the first tab, the Dimensions tab, I'm going to choose to select by surface. And you can see as you start selecting the surface, it begins to build that feature for you quite easily. So I'll hit apply on that one, and I will start to click again on the other side to get that second feature. Hit the green button to accept, and there we go, we have our features. So in this one, the slot is too wide for this 1-inch end mill to machine it with one pass. So we are going to have to go through a roughing process with it. So from the Home tab again, Strategy Selector, Feature Machining. So the last time we used the Feature Pocket Profile, this time we're going to use the Feature Pocket Area Clearance. The setup is going to be very similar to other model area clearance toolpaths if you've used that before. And we will run through those settings quickly. I'm going to choose an offset model style. All my preferred settings. Once I have the toolpath set up the way that I would like, I will go ahead and calculate. So there we have a fairly simple roughing style strategy that goes through and roughs those slots all the way through the plate. Using the same features that we have here, I will then try the feature pocket profile like I did before with the orange slots, green slots, excuse me. Make sure my settings are the way that I would like, and calculate. The side purple pockets or slots are now done. Last, I'm going to have a look at these inside large bores that are otherwise too large to drill. So we'll have to use some kind of milling operation to get them. And this one is a bit different because there are multiple diameters inside of this feature itself. So again, from the feature groups, I'm going to choose to automatically detect these features. Now, I showed you earlier about the single feature, and then I also showed you about the similar, where it would find multiples that are the same. let's look at hierarchy. So hierarchy will identify, similar to a compound feature set, a multiple feature assembly in the model. And if you notice, you can just go around, click these, hit accept, and now you have a feature that has multiple diameters or multiple components inside of it. The strategies are going to be the same as we used before. This time I'll use offset all, adjust my settings accordingly, and calculate. All right, there we go. We have the roughing style toolpaths for these features. And keeping with the same settings, I will jump into the profile. Again, adjusting all of my settings. Okay, close that form down. So you can see there may be advantages to both styles of machining. I would say that the feature machining is a little bit more user-friendly, but you might be able to get away with some more custom style shapes with the curve machining. So it's your choice which one that you want to use.
Great, great. Thank you very much, Mike. I think you've shown these strategies very well and highlighted how they are really both valuable and offer you, the programmers, the flexibility, right? Because of the variety of applications that we're all going to be tackling. So, all right, we now find ourselves at the Q&A portion here. We've had a couple come in, and I'm just going to launch right in it. And of course, queue you up, Mike. So
Okay.
the first question coming in, uh, if I have pre-existing wireframe, can I use them for pattern machining?
Oh, absolutely. In a similar method, and jump back into the project here. In a similar method, if you have pre-existing wireframe, you can, create that new pattern and either trace it with a comp curve, or you also have the option to, choose those pieces of wireframe, whatever they are, and actually import them or insert them as a model. If you'll notice down here, you can say insert model with whatever edges you have chosen. So that's a pretty easy method right there.
Wonderful. Next question is, can you utilize tool compensation with the 2D toolpath shown?
For sure. So there's always the option to do it at the controller. Obviously, you can use the cutter comp there, which can be turned on, but there's also some flexibility here inside the NC program. So if you create that NC program, when you get to it here, you can actually turn on cutter compensation down there and then choose how exactly you do want to use that cutter comp. I'm not going to get too in depth with how this works and how to do it. You can either reach out to us and we can send you some documentation on it, or I believe there may even be some articles up online at on the Autodesk Knowledge Network. But yes, the cutter comp is a possibility.
Yep, thank you for that. And actually, that's a good point. I'm glad you brought that up. Some questions could be pretty in depth, maybe, and might carry into a bit of time or an extensive conversation. So we can certainly follow these up, and we'll queue up a slide at the very end with our contact information, so we could follow up like that. And of course, you can toss us a personal email afterward as well. So let's jump into the next question. Are 2D toolpaths in PowerMill able to recognize a stock model?
Oh, absolutely. Yeah, you can use them to recognize stock models and use it with your usual workflow if that is a part of your usual workflow. So there shouldn't be any issues with that.
Okay. This is regarding 2D. Well, of course, this whole segment is regarding 2D. Very good. Do 2D toolpaths in PowerMill show gouges and collisions like 3D toolpaths?
No, not like a normal 3D toolpath, but if you notice when I went through the process, I did get the white check mark. If you're using this already, or if you start using it after this, you will notice a lot of the times you get a yellow question mark. That is because when you create the pattern, if that's what we're talking about, essentially you are only machining this pattern. It's not actually machining the surface model that you see. But I think I went over it fairly quickly, but in the toolpath form here, wait for it to come up, you'll see that there is some verification. So you can add a model gouge check. So it does the check while you're creating the toolpath. But if you don't have this checked, it will just simply create this toolpath where the pattern is, exactly how you asked it to do it, down to the level you've defined, and give you the yellow check mark. And of course, if you don't do it here, you always have the option in PowerMill from the verification group to verify for both collisions and gouges. So you can get the same result to ensure that you do have that safe toolpath.
Of course, and I'm glad you stressed that last one there, because that's always been sort of a flagship feature there, that the safety and the security of the toolpaths that are calculated in PowerMill.
Absolutely.
Okay. The next two were pretty much already hit on. I'm just going to reiterate, but I think they were just covered. Is a 2D curved toolpath using the model or just a pattern? And you did just answer that one right over there. In essence, it can do both, or just do one on its own and collision check afterward. So that one is good.
Yep.
And the follow-up to that was, if we're just using the pattern, how certain are we that the tool is not violating the model? So it looks like that one was knocked off as well. So
yeah.
Okay, I'm going to take a quick moment, and I feel one just came in here, so let me have a quick peek. Oh, when you pick your pattern, does it matter if you use the top of the feature or the face of the feature? Like, does it matter if you use the floor, the top, anywhere on the model?
No, it's as far as the Z value is concerned, you're going to be driving that with the numbers inside PowerMill. If you remember, we picked the lower limit for the lower limit, and then it can be the top of the block if you want. I'm gonna be honest, I've always used it that way, but my pattern I usually have above, and I machine down from it. So yeah, if you actually look here, it starts at the top of my block, not necessarily at the top of the pattern. If you can see that. Oops, just lost my view here. And there we go. And then like I picked right there, this bottom floor, which has a Z value of 1 inch, and I entered that in there. So The pattern, the way I always kind of explain that is that it matters that it's from the top view. So if I go Control-5 from the top and undraw this, you can see the orange pattern here. That's the way PowerMill is seeing it. The min and max Z value height is driven with the information that you plug into it.
Okay, great there. Yep, and yeah, we saw your screen there. It looks like you have the same problem as me. Perhaps you're over caffeinated, and that's why the model was flying around there for a moment. But good, you showed it well. There's another question here: are features editable from feature groups? And you don't necessarily have to launch into it, but in general, can you
Yeah,
edit them?
in general, absolutely. You can hop in there. There's some editing tools inside the feature groups. I mean, like Rob was saying, we're not going to get into a detailed description of it, but you can see here up at the feature groups, feature editor, and you have a whole host of tools to both create and edit the features. So again, there is a lot of documentation about this online, or if there's a very specific question, feel free to reach out. I'm happy to put something together for your specific questions.
Great then, and I believe we got a slide for that. Look at you, quick on the draw, mister. So right over here, this is the contact page for us. As promised, we were trying to keep this into a nice tidy delivery, and we're right about on that mark there. We will be hosting more webinars to come, so we will certainly make sure to pass along the invitation to all registrants today. If there were any audio issues or any concerns in that regard, or if you missed something, we could get a recorded session from today, pass that along to you. So you've got our email address, you've got our phone numbers here, and we just appreciate you carving out that slice of time today and hope to see you joining us again. So thank you very much.
Thanks, everyone.
Thank you.